Hello, I'm Jinju Wang. In today's tutorial, we will talk about the reports and the tools of Luto. Specifically, we will explore how Luto organizes all the solutions into an HTML-based graph and maps. Further, we will talk about how to deploy Luto on the high-performance computation nodes so that we can run multiple Luto runs in the same time. First, let's have a walkthrough of how to write the solutions into Excel files, into GOT files. The write module lives in Luto tools write.py. And we can see this is a nearly 1,300 lines of code. The first function of write module is the write output wrapper function. Inside this function, it is executing two commands. First, it writes data. The next is logs. Inside this write data function, there are two key points. The first thing is for writing output, we write for single years each time. However, we use a list to wrap all the write function into a list, and then we feed this list to this parallel function, so that we can write all the output at the same time using multi-thread. Another point is we create the report HTML using these three lines of code. In the first line, we have transformed the GOT files into the format that can be displayed inside an HTML. In the second command, we have transformed all the Excel CSV format into a JSON format. This is also for the purpose to display them in an HTML. In the third command, we have copied all the output into the web page so we can see them visually. The key function for write lives inside this write output single year function. Scrolling down, we can find this function is a wrapper function which write decision variables, write quantity, revenue, water, greenhouse gas, and biodiversity. So this is where all the transformation of Groby solutions into the output files. Each time after successful running, Luto will create a new folder in the output directory. For example, we can find the output in this output directory. Depending on the mode, the output can be categorized as time series and snapshot. For snapshot run, the output folder will have two directories corresponding to the start and ending year, and it will generate these logs. Each log records all the information during the process run, starting with this timestamp. This is a tool for debugging. And this is the report directory. Here we just need to double click. We will inside this report HTML, and then we get into this directory. All the report can be visually inspected inside this page. When we double click, we will get the full report. If the running is under time series mode, when we get into the output folder, we can find new directory for each year during the running process. Similarly, we can see some logs, and also we can see a data report folder. Unlike in snapshot mode, the time series mode will create begin and compare folder. This is the comparison between the starting year and the end year. When we get into the data report folder, in a similar way, we can hit this index HTML and it will give us the report. Let's use the time series to illustrate the result. For example, this area. When we run this command, it will create the output for each folder. Let's get inside a random folder. And this three output is the result comes from this right dvar area. Let's open up the agricultural land use for 2015. And here is the general look. The first column is a year, second column is water supply, And here, in this year, for each specific land use, what is the total area in hectare of the land use? Similarly, we can get the output of this quantity module. We double-click this quantity module. We can find for each land use in 2015, what is the total production in tonnage. Some of the output can have multi-leveled attribute, for example, greenhouse gas emissions. When we open up the greenhouse gas emission for land use, we can see that for each land use, it will have different emission type. For example, it will have like a dozen of emission types. Although we can manually open up the output for each specific year, it is hard for us to see the general trend of the area or the greenhouse gas emission. That is why we introduced the report module in Luto. The report module is under Luto, Tools, and Report directory. Here we can see 3 files corresponding to generating the report HTML. Let's first open up this create static maps.py file. After executing this file, Luto will create and map the GOT files in the output folder. For example, let's get inside the output folder for 2016. We can find this GOT file has an accompanying PNG file. Scrolling down, we can see every GOT file has an accompanying PNG file. These PNG files are standalone files. We can double-click and observe the patterns in this year. And we can also share this file with others simply by dragging or email this file. Another important part is this create report data.py. After executing this file, all the CS files in each of the annual folder will be merged and converted into a JSON format inside this data.report. Here we can double-click this data and observe this total area.json file. We can see that for each land use, their records across years has been recorded into this JSON file. At last is this create HT file. After executing this file, all the maps and JSONs will be merged into a web page for visual inspecting. Another important tool helps deploying Luto on the high-performance computation node. This enables Luto to run multiple scenarios at the same time. The code of this tool lives in Luto, Tools, and the Create task runs. Here we will mainly demonstrate how to use this tool. Before getting started, it has to be confirmed that the high-performance computation node is running on Linux and managed by a Slurm system. Now, let's open up the mobile Xterm software and click this session to connect it to the HPC. Here we choose the SSH session, and in here type in the address of the HPC node. For example, hpc.deacon, and specify your username and a port. If all those informations are successful, you can click OK to proceed. After logging into the HPC node, make sure you have successfully installed Groby Optimizer and acquired license. Also, please make sure you have set up the working environment and cloned the code from GitHub successfully. To deploy the Luto on HPC node, the first thing is to check what is the name of the node. The command is sinfo. When we hit enter, we can get these names of each HPC node. At last, please make sure the Luto model has all the necessary data. For example, here, when I open the input data, it has all the necessary input files. Now let's start to deploy the Luto runs on HPC. First, we need to change directory to the Luto folder. For example, my Luto code was inside this capitalized Luto 2.0. This is the path to the Luto code. So I will copy this path and cd to this path. Now I'm inside the Luto folder. The next step is to activate the environment, which is the command command activate Luto. To check we have successfully switched the environment, we need to inspect the environment name has changed from base to Luto. At last, we can type in command ipython, which will lead us to an ipython session. Sometimes the ipython will not return a new session to us and the terminal will freeze. In that situation, we need to get into one node first. For example, we can see we want to run our Luto in mem, so we can get into the mem node first. The command is srun -p, means the name we want to get into mem, --pty bin bash. This one means that when we get into the mem node, the first command we want to execute is bin bash. Now we can see that we have changed the node name from log name to this fcb1, which is the name of mem. Now we can create multiple scenario runs using Luto. First thing first, command activate Luto, get into the Luto environment, and then change the directory to Luto code. Here is my Luto directory. And then type in ipython to start an ipython session. First, we need to import the helper functions, which is from luto.createTasks.helpers. Import this creating settings template helper function, luto.tools.create_task_runs.helpers import create settings template. Now we have this create settings template. We can double click this and right click, just enter the double bracket. And now when we execute, now let's get to the Luto directory. We can find there is a custom runs folder. Inside this folder, we can find this settings.template.csv. We can double click to open up this template CSV. And in the first column is all the settings names, and in the second column is the default parameters for each variable. We can copy this default run for several times and give it a sensible name. Here I'll just give it a run1, run2, and run3. So here's the deal. Whenever we add a new columns to this file, the Luto will create a separate run using all the parameters of this column. In this example, I will change the scenario of temperature expectations. For example, in this GHG limit field, I will change the run1 to 1.550, leave this the same, and the third one of 1.867. This field representing the different climate change expectations in the future for Luto. At last, we need to specify the node name for Luto to run. For the following three columns, I want it to run on the node of mem. You can leave the memory, CPU, time, and job name as auto, so that Luto will automatically compute all those values for you. Now, let's save this file and go back to the terminal. From the terminal, we need to import create task runs from luto.tools.create.task.runs.helpers, the same directory. Now we just need to copy this function name and close the bracket. And when we hit enter, we can see we are submit the jobs to the node. Now we can exit to observe what's happening. To inspect the submitted tasks, we can use the command sque. Now I can see that this is my name. I have submitted 3 Luto runs to the node of mem. So what is the output looks like for multiple scenario run? Let's get inside this custom run directory. We can see that there are 3 folders corresponding to the 3 columns we just specified. And within each folder, it is an independent Luto directory. So inside each output directory, we can see Luto is out generating result here. Okay, this is how Luto organizing the reporting and deploying the multiple runs on an HPC. The tutorial is only suggesting an example to run Luto simultaneously. You might need to refer to your school manager on how specifically you can deploy the runs on a Linux system.